Hello students, good evening. Good evening everyone. Can you hear me? All of you? Say hi everyone. Good evening. Okay, so we are in the fourth session of our YouTube live revision classes, and today we are going to see sessions on wave optics and ray optics, and I hope you will share this link with your friends so that they can also benefit. Okay, ask your friends to join. Okay, right. Yeah, good evening everyone. Good evening Russell. Good evening Gayatri. All of you, Sujay, Hibba, all of you. So let's wait for one more minute. Now hope your preparations are going well. We got like 2 more days left. Tomorrow and day after tomorrow. Are you worried? Are you scared? Are you scared? Not at all. Very good. Yes, we are going to create history this time. Okay. Right. No need to worry at all. Physics won't be hard. You will score really well. Do not worry. You still have 2 days left. Give your best. And over the next 2 days, study at least 12 to 14 hours a day. And that will give you at least 30 hours of sessions, preparations. So that will be more than enough to get you the extra edge. Okay. Am I clearly audible, everyone? Can I have a reply here? So we'll be starting off with a revision session on wave optics first. We will do wave optics. Then once I'm done, Rafi sir will do ray optics. Okay, right. So shall we go straight away to the questions? Everyone? Come on guys, tell me. Yes. Okay, right. Okay, so let us go to the first question. In Young's double slit experiment, if the widths of the slits, just give me a second. If the amplitude ratio of 2 sources producing interference is 3:5, the ratio of intensities at maxima and minima is. Now, before I do this question, I'll tell you about the theory. Now, do you remember what Young's double slit experiment is about? We have a source of light. Okay. And we have a source of light and you're keeping a screen in front of it. What do you see now? There will be uniform illumination on the screen. Okay. You're just projecting light onto a screen. All right. And what do we have now? Everywhere across the surface, light will be evenly distributed. Right? Okay. Right. Now, right in between, I'm bringing a pair of slits. What is meant by a slit? You are just making a cut using a blade. Now this is called a slit. All of a sudden, you see something extraordinary on the screen. What is it? Now we have a pattern on the screen, consisting of alternate bright and dark bands. The central band is always a bright band. You know the reason for it. Then alternate bands are dark. This phenomenon is called interference, and the experiment is called Young's double slit experiment. Okay, the phenomenon is called interference of light. Okay, right. So I'll repeat the experiment one more time. We have a source of light. This is like a source of light with wavelength lambda. Then in front of that, you are keeping a pair of slits, and at a distance you have a screen. So on the screen you have a pattern. What kind of a pattern? You know, the pattern has alternate bright and dark bands. These bands are called interference bands, and the phenomenon is called interference. The experiment is called Young's double slit experiment. Okay. And while learning this experiment, we learn the intensities of the lights as IA and IB. The intensities of lights are IA and IB. Intensity of light coming from the first slit is IA. Intensity of light coming from the second slit is IB. Usually they will be the same unless given otherwise. Okay, sometimes they'll give like one is I, the other is 3I, or one is 4I, the other is 9I. Usually, both the intensities will be same, right? So anyway, I'm going to write few equations. How do you find the resultant intensity? Resultant intensity is given by IA plus IB plus 2 root of IA IB into cos phi. Now this is the equation for interference or superposition. Alright, you might have learned this already. Okay, I is equal to IA plus IB plus 2 root IA IB cos phi. Now there we learned something. What is the ratio of I max to I min? Maximum intensity to minimum intensity. What is this? That is given by root of IA plus root of IB the whole square divided by root of IA minus root of IB the whole square. Okay, or A plus B the whole square divided by A minus B the whole square. What is A? What is B? I forgot to tell you. The waves are A sin omega t and second one is y1. This is y2 is B sin omega t minus or plus phi. Okay. Now the amplitudes are A and B. Amplitudes. Amplitude means maximum height of the wave. Maximum height of the wave. Am I correct? Maximum height of the wave. Amplitude is maximum height of the wave. Okay. Now you got what? You can divide everyone with B so that you are getting A by B. This is A by B plus B by B is 1. The whole square by A by B minus 1. The whole square. You need to learn these equations by heart. And there is one more I'll tell you, that is regarding width. Width of a slit. Width of slit A by width of slit B is given by A square by B square. I presume your teacher has taught this for sure because it is so important. Reader has a question on this and it is a previous question also. Width of a slit is related to amplitude as WA upon WB is equal to A square by B square. So let me summarize this one more time. Look at this. This is Young's double slit experiment. We are talking about Young's double slit experiment. Okay. Now we have two slits here. They are called slit number 1 S1, slit number 2 S2. Then light is coming out of it. Alright. These lights join together to create a pattern on the screen. We have dark band as well as bright band. Okay. Anyway, the resultant intensities equation is what? IA plus IB plus 2 root IA IB cos phi. Say it again. IA plus IB plus 2 root IA IB cos phi. What is IA? Intensity of first wave. What is IB? Intensity of second wave. What is phi? That is something called phase difference. Phase difference. Okay. And I max to I min ratio. This is something very important. I max to I min ratio is what? Root of IA plus root of IB the whole square divided by root of IA minus root of IB the whole square. Alright. So that is also written as A plus B the whole square by A minus B the whole square. If you divide throughout with B, you are getting what? A by B plus B by B is 1. A by B plus 1 the whole square by A by B minus 1 the whole square. Right. This is called amplitude ratio. Amplitude ratio. Say it again. Amplitude ratio. Amplitude ratio. Okay. What is amplitude of first wave? A. Amplitude of second wave? It is B. Okay. And I also told you one thing. Width of a slit is related to the amplitude as WA by WB is equal to A square divided by B square. Is this much clear? Everyone, we'll go to question number 1. Please tell me, everyone. Can I have a response, please? All of you guys, tell me. Everyone. Right. The faster you respond, the more we can do. Right. Right, right. Thank you, Martin, Sadiq. All of you. Right. Okay, right. So let us go to the question now. Hope you have written this. I'm going to use this equation here. See this now? See this now? I'm going to use that equation. Now, what is the question here? They are asking about if the amplitude ratio is given, the ratio of intensities. Amplitude ratio is given. Amplitude ratio is what? Amplitude ratio is given as 3 by 5. Amplitude ratio means ratio of amplitudes. So that is what? 3 upon 5. Amplitude ratio is 3 upon 5. Okay, they are asking for ratio of intensities at maxima and minima. Very important question, very important question. I max by I min. You have to calculate. How do you find it? Tell me. A by B plus 1 the whole square divided by A by B minus 1 the whole square. Okay, you're surely going to get this question. Right, A by B plus 1 the whole square by A by B minus 1 the whole square. Tell me, you can put it over here. A by B is here. I can put it straight away to this. 3 by 5 plus 1 the whole square by 3 by 5 minus 1 the whole square. Okay, that is equal to 5. LCM is 5. 5 into 1, 5. 5 plus 3. 8 upon 5 the whole square divided by 3. 5 comes here. 3 minus 5. That is minus 2 upon 5 the whole square. So let us expand this. 8 square 64 and 5 square is 25 divided by minus 2 square is 4. 5 square is 25. So let us cut the common terms out. Tell me what you're going to get. 25 gone. 64 gets gone with 4, leaving you with 16:1. The ratio is finally 16:1. Is that clear, everyone? Everyone, can I have a response, please? All of you. Come on, guys, what is this? Tell me. See, I'm going to do 10 questions and that will cover the whole chapter. Okay, trust me on this. This will cover the whole chapter. Once I'm done with the questions, we will have a total revision of the whole chapter. Okay, right. That is how I've set the paper. As I told you yesterday, all our teachers, all our experts are investing so much of time into this. Okay, as I told you, this is done with an intention. This is done to help you. Otherwise, we wouldn't have tried at this 11th hour. All right. Okay. Right. This is all done to help you. Okay. Right. So, please tell me. Right. Come on. Moving to the next question. In Young's double slit experiment, the widths of the slits are in the ratio 4:9. So, width ratio is given. Width ratio is 4 by 9. Width of what? Width of slit. I told you there are two narrow cuts using or called slits. Now the slits are in the ratio, slits widths are in the ratio 4:9. 4:9, right? 4:9. Okay, right. Let's get back to this. All right. What am I finding now? Let us get back to the question. The ratio of intensity at maximum to intensity at minimum. How am I finding it? I max to I min. I max to I min is equal to. Before I do that, see what I wrote here. Width of a slit by width of second slit is the ratio of squares of amplitudes. Squares of amplitudes. Say it again. So I have, this is width of A by width of B is what? A square by B square is 4 by 9. Width ratio is given. Width ratio is what? A square by B square is 4 by 9. Tell me what? You take, width ratio is given in the question. That is A square by B square is 4 by 9. What is A by B then? A by B, take the square root. Square root, that's going to be what? 2 by 3. 2 by 3, yes. I can put it back here. Now, let us get back to the equation. Do you remember the equation? I wrote an equation like this. A by B plus 1 the whole square by A by B minus 1 the whole square. This is called maximum to minimum ratio. Right. I max to I min ratio. Now try it yourself. It's so easy. Right. It's cakewalk for you. Right. Tell me what? A by B. I got an over there. Tell me 2 by 3. 2 by 3 plus 1 the whole square by 2 by 3. 2 by 3 minus 1 the whole square. The whole square. What do we get? What do we get? What do we get? What do we get? Tell me. 3 comes here. 3 plus 2. 5. 5 by 3. Tell me. That is 25 by 9. Divided by 3 comes here. 2 minus 3. Minus 1. Minus 1 square. 1. 3 square. 9. Now, cut them out. You are getting what? Finally, the ratio is 25:1. That is also equally important. Reader has a question on this. It is not explicitly mentioned in the reader syllabus. Okay? Right. All of you got this? Everyone, everyone? Yes, 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 Sadiq. Very good, very good. Right. All of you, could you please tell me? Everyone, everyone. Right, Martin. Right. Thank you. Everyone, everyone, please. Come on, guys. What is this? Right. Right. I think you're scared, right? No, 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 no. No need to worry. No need to worry at all. Right. So, third question. Moving to third question. In Young's double slit experiment, intensity at a point where the path difference is lambda by 6. Path difference is lambda by 6. The wavelength of lambda being wavelength of light used is I. So, path difference is lambda by 6. I'll tell you something now. Path difference, lambda is related to phase difference as what? Phase difference, path difference lambda corresponds to phase difference of 2 pi. That you have to learn by heart. Path difference of lambda corresponds to phase difference of 2 pi. Path difference of lambda corresponds to phase difference of 2 pi. So, path difference of lambda by 2 corresponds to phase difference of 2 pi by 2. Lambda by 3, 2 pi by 3. Lambda by 4, 2 pi by 4. Lambda by 6, 2 pi by 6. Okay, put the corresponding number on the right side also. That's it. Okay, why do we need phase difference? Because our original equation has phase difference. I is equal to IA plus IB plus 2 root IA IB cos phi. So, let us see this now. In a Young's double slit experiment, intensity at a point where the path difference is lambda by 6. So, path difference is what? Path difference is lambda by 6. When path difference is lambda by 6, phase difference is 2 pi by 6. Path difference lambda corresponds to phase difference 2 pi. Path difference lambda by 6 corresponds to phase difference 2 pi by 6. Now, let us get this cut. That is going to give you pi by 3, right? Pi by 3, right? So, I am writing that equation for intensity. They have given it as intensity I. What is it? IA plus IB plus 2 root IA IB cos of phi. Phi is what? I've got it over here. Phi is pi by 3. Cos pi by 3. Pi by 3. Do you understand? Do you understand? Everyone? Everyone? So, what is this? This I and this I are different. This I and this I are different. Do not cut them. Do not cut them. Do not cut them. This I is what? This I, resultant intensity. Now, this is individual intensity. Individual intensity coming from each slit. Alright. So, let us solve this. I plus I, 2I plus 2 into root of I into I. Root of I square. Root of I square is what? Come on. Root of I square is what? I cos pi by 3. Cos pi by 3 is cos 60. Cos 60 is 1 by 2. So, let us cut 2 and 2. What do we get now? What do we get now? This is equal to 2I plus I, that is equal to 3I. So, I've got the value of capital letter I as 3 times I. That is my equation number 1. Now, they are talking about something else. If I0 denotes maximum intensity, I0 denotes maximum intensity. How to get maximum? I told you already, root of IA plus root of IB the whole square. That is how you find the resultant intensity maximum, right? Resultant intensity, right? Resultant intensity, right? Okay. No, 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 no. Don't worry. Don't worry. Nothing will happen. Why do you think about passing? Passing, you know, that will automatically happen. You are never going to go below 60. 100% sure. Trust me on that. Okay. I've seen this for 21 years now. 21 years now. All right. Now this is never going to be so hard as you think. All right. Okay. Yes, yes, yes. Just be confident. Now, after all, see, at the end of the day, this is never going to be a big deal in your life, right? It is just another examination at some point of your lifetime. You can do even bigger things, better things. All right. You are a better stuff. Then why worry? All right. Okay. So when you were in LKG, okay, when you were in first standard, you cried a lot over what? Over silly things. Now do you worry about it now? No, no. Now this is never, yes, this is never going to affect you in a bad way, right? 100%. Okay, just be confident, just stay cool, right? Okay. So you are the last one to believe in you, all right? Then if you lose the confidence, who else will believe in you, right? Okay. No, no, no. So do not worry about it at all. Trust me, right? Okay. 100%, 100%, do not worry. See, I have seen many students in my career who never, see, I've seen many times, I've told many times my classes, you know, who students who never passed a school examination getting past 95 mark, getting past 95 score. That is not a big deal at all. All right. Now, just believe in one thing, this is not going to be the end of the world. Okay. That is just another day, just another exam. Okay. Right. I don't know why everyone is so scared. No need to worry, no room for being scared. Okay. Right. Yeah. So if you're worried, you just remember me while writing the exam. Everything is going to be all right. Okay. Right. So this is what? Root of IA plus root of IB the whole square. Root of IA plus root of IB the whole square. I max. What is it? IA is I. IB is also I. Both are same unless given otherwise. Unless given otherwise. Usually both are same. So what are you going to get? Root of I plus root of I the whole square. That is equal to what? That is equal to 2 root I the whole square. That is equal to what? That is equal to 4 times I. 4 times I. That is 4 times I. So I got I0. They are asking you to get the ratio. What is ratio? I by I0 ratio. I was 3I and I0 is 4I. Cut the common terms out. Finally, you are getting 3 by 4. 3 by 4. Is that there in the options? Let us check it out. 3 by 4 is there in the options? Yes. 3 by 4. Got it? Option D. Yes. Option D. Okay. Right. Everyone. So should I repeat this? Now it is very simple. First case they say path difference is lambda. Path difference lambda means phase difference is 2 pi. Path difference lambda by 6 corresponds to phase difference of 2 pi by 6. 2 and 6 are cut. Pi by 3 will be the phase difference. Okay. Pi by 3 will be the phase difference. All right. And you know, I'm writing the intensity first. IA plus IB plus 2 root IA IB cos phi. Okay, right, cos pi by 3, phi value I got it over here, right, I put it back and I'm getting what? I plus I, that's going to be 2I, then 2 into root of I into I, that'll be what? That'll be I cos pi by 3 is 1 by 2. Cut those 2's out. You're getting what? 2I plus I is equal to 3 times I. So I've got my first equation. Next equation is what? They're talking about maximum intensity. How to get the maximum intensity? Tell me. Root of IA plus root of IB the whole square. I told you already, right? 2 root I the whole square. 2 root I the whole square is 4 times I. So I by I0 is 3I upon 4I. That is going to give you 3 by 4. I'm going to the next question. Hope it's okay for you. Right. Now, if you respond, I'm going to do a live session tomorrow maybe, right, on modern physics. You know, all important questions from all chapters will be done. Modern physics chapters. Atoms, nuclei, dual nature, electronic devices. All right. All important areas I'll cover. Like 2.5 hour session. Okay. If you're ready to come and if you're okay, we will do it. Now, let us look at next question. In Young's double slit experiment, the fringe width is found to be 0.4 mm. Fringe width. Fringe is another name for band. I told you interference has what? Alternate bright and dark bands. Alternate bright and dark bands. Interference is responsible for colors on the wings of a butterfly. Colors on the wings of a butterfly are due to interference. And colors on soap bubbles. Soap bubble. If you take a soap bubble and if you look around, you can see colors on it, right? Yes, that is due to interference. Anyway, you know, in interference, in double slit experiment, you see a pattern in which bands are there. And each band is also called a fringe. They have given you the fringe width. Fringe width is how much? Fringe width is 0.4 mm. 0.4 mm. Okay, 0.4 millimeters. If the whole apparatus is immersed in water, this is one of the most repeated questions in the history of CBSE examinations. Okay, if the whole setup, I'm damn sure that you have seen this at least once in your school classes. Okay, if the whole YDSE setup is immersed in water of refractive index 4/3, look at that. That number is also given without disturbing the arrangement. I'll write down the equations now. Look at this. I have like some equations. First one, width of a band is given by, interference band is given by lambda d by d. Lambda d by d. Lambda d by d. What is lambda? The wavelength of light you're using. What is capital letter D? The slit screen distance. What is small letter d? The distance between the slits. Okay, right, okay. Okay, right. So, beta is equal to lambda d by d. This is what? Irrespective of whether it is a dark band or a bright band. Irrespective of whether it is a bright band or a dark band. The width is given by lambda d by d. Lambda is the wavelength of light you're using. Capital D is the distance between slits and screen. Small d is the distance between the slits. Yes, Muhammad, that's right. Okay, and if it is immersed under water, the setup is immersed under water, we have an equation beta dash is equal to beta by mu. Mu is called refractive index. Mu is called refractive index. So when you immerse the whole setup inside another medium, you know, beta will change to beta by mu. You can prove it mathematically, which is not needed. Okay, now the third point I'll tell you. Distance from center to the nth bright band. Distance from center to the nth bright band. Distance from center of the screen to the nth bright band. Third bright band. 9th bright band. 12th bright band. Distance to the nth bright band is given by n lambda d by d. And distance to the nth dark band is given by 2n minus 1 into lambda d by 2d. Letters have the usual meanings. Letters have the usual meanings. Letters have the usual meanings. Then 2 more to go. Done. Right. So simple. Angular fringe width. There is something called angular fringe width. Angular fringe width. Nothing. It is the angle made by a fringe at the slits. Angle made by the fringe at the slits. Just know the equation lambda by d. Now if it is underwater in a medium, theta dash will be theta by mu. Just like beta dash is equal to beta by mu. Trust me, this is again one of the most important slides here. Right. You know, all these questions are based on what? Based on Young's double slit experiment. Say it again, Young's double slit experiment. Look at this. First is width of a band is given by lambda d by d. Width inside a medium. Inside a medium. Width inside a medium. For example, underwater. Okay, it is given by beta by mu. Width in air divided by refractive index. Width in air divided by refractive index. Then distance to the nth bright band. Distance to the nth bright band is given by what? Look at that. From center to the nth bright band, if you need to find the distance, this is what you're going to do. N lambda d by d. Put the number here. If it is 9th band, put 9. If it is 7th band, put 7. If it is 10th band, put 10. Okay, 10 lambda d by d. And if you want to find the distance to nth dark band, this is our equation. 2n minus 1 into lambda d by 2d. Then this is called angular fringe width. Angular fringe width is what? Lambda d by d. Angle made. Angular fringe width. That is directly asked. Only directly asked. Angular fringe width. Now angular fringe width inside a medium. Inside a medium. Angular fringe width inside a medium. You can take a screenshot or you can write this down. This is fringe width inside a medium. This is angular fringe width inside a medium. Fringe width inside a medium. Angular fringe width inside a medium. Okay. And the last case, I'll tell you, lambda's variation, I can tell you. Violet, indigo, blue, green, yellow, orange, red. What do you understand looking at this? What do you understand? When you go from violet to red, wave alphabet size increases, right? Alphabet size increases, right? Okay, which means wavelength increases when you go from violet to red. Wavelength increases when you go from violet to red. When wavelength increases, automatically beta also increases. Beta also increases. This is a frequently asked question. They'll say like, you are doing the experiment with yellow light. You are doing the experiment with yellow light. Yellow light. Which experiment? Young's double slit experiment. We are talking about interference, right? Okay, so Young's experiment, and then you are changing the light to indigo. What will happen to width of the band? Common sense. Common sense. Common sense. Look at that. Yellow is changed to indigo. Yellow is changed to indigo. What will happen? Look at the size of alphabet. Size of alphabet gets shorter, right? So wavelength decreases. When wavelength decreases, beta also decreases. Width of band decreases. Or they might say like interference was being done with the blue light. You change it to orange light. What will happen? Can someone come and please? Can someone come and please? Blue to orange. When you change blue to orange, what will happen? Can you tell me please? Blue to orange. Blue to orange. Yes, Gayatri. Very good. Very good. Blue to orange. Blue to orange. Tell me. Blue to orange. Blue to orange. The size of the alphabet increases. Size of the alphabet increases. Size of the alphabet increases means wavelength increases. Wavelength increases means beta increases. Width of the band increases. Yes, Martin. Yeah. Yes, Gayatri. All of you, please. Gabby. Yes. Everyone. Tell me. Come on, everyone. Can you please tell me? Right. See, get yourself charged up because you are writing the exam in 2 days' time, and after this you will have at least whichever program you choose, whichever professional program you're going to join in, you are surely going to get at least 3 months of vacation. Okay, you can enjoy your life then. Don't worry. All right. Yes. You can enjoy. You have so much of time left. No. So just let this exam get over. After that, you can relax. Okay, you can be with your friends. You can go to the places where you want. Right. Okay, just look at life in a positive way. Right. All right. Now, one simple exam cannot do anything bad to your life. Okay. Right. When you fall down, you wake up and then what? You start running, right? You get up and start running. That's it. Okay. So just have the spirit with you all the time. Be a fighter and fight things out. Okay. Right. All right. There are bigger and better things to come in your life. All right. Do not worry about anything. Okay. Right. So this is such a question. It is immerse in water. Immerse in water. I told you. Immerse in water. Beta by mu is my equation. Immerse in water. So let us put it here. Beta dash equal to beta by mu. What is beta? Beta is there in the question. 0.4. Mu. It is water. So refractive index is 4/3. Then this and this are cut. It is 0.1. 0.1. This will go to numerator. 0.1 into 3. That is going to give you 0.3 millimeters. Why millimeter? Because the question is given in millimeter. So 0.3 millimeters. Answer is option A. All of you got this? Faster, 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 please. Everyone, I got only 20 minutes. I got 7 more questions to go. 8 more questions to go. Each and every question is important. You can request us for the slide after this if you need. Okay. There are few more important questions at the end of every session. I'm not able to finish the questions. Okay. Right. As I told you, these questions are carefully selected. So high chance of coming. Right. Moving to the next question in sodium light in Young's experiment. Sodium light. What is sodium light? Sodium light. Can someone tell me? Have you seen sodium light? Have you seen sodium vapor lamp? Have you seen sodium vapor lamp before? Oh no, what is this? Sodium vapor lamp. Haven't you seen sodium vapor lamp? Sodium vapor lamp, the yellow color street light. Yellow color street light. Yes, yes, yes. Very good, very good. Yes, the yellow street light is sodium vapor lamp. So sodium, the moment you see sodium, you must think about yellow color. Yellow color. Yellow color is replaced by red light. Yellow is replaced by red light. Look at that. Lambda, violet, indigo, blue, green, yellow, orange, red. I already gave the answer to this question, right? Yellow color. How do we know yellow color? Sodium light is always yellow. Sodium light has actually 2 colors. Sodium 1 and sodium 2. Sodium 1 is 5890 angstrom. Sodium 2 is 5896 angstrom. Alright. Anyway, sodium is yellow. So you're changing yellow to what? Yellow to red. Look at that. Look at the sequence. Yellow to red. Yellow to red means what? Wavelength increases. Tell me, wavelength increases. What will happen? You know, beta was lambda d by d. Now you tell me, when lambda increases, beta also increases. Beta also increases, right? Beta also increases. Yes. So beta increases. Beta will increase. Answer is option B. All of you got it? All of you got it? Tell me, please. Everyone. Yes, Mohammed. Thank you. Gabi. Right. All of you. Yeah. Let us move to the next one now. 6th question. In Young's double slit experiment, angular fringe width. Angular fringe width. I told you what angular fringe width is. Angular fringe width is 0.2 degree. Angular fringe width is 0.2 degree. Angular fringe width is 0.2 degree. 0.2 degree. All right. Angular fringe width is 0.2 degree. So it is given angular fringe width is 0.2 degrees. All right. Keep it in degrees. Answer is also in degrees. Right. You don't have to convert it to radians. All right. Usually it is mandatory to convert to SI system. Right. So degree measurements have to be converted to radians. But this time we don't do it. Tell me why. Because answer is also in degree measurements. Right. So let us do that. So they are asking about what? Oh, I didn't read the question. My bad. Tell me if complete system is dipped in water. Look at that. Dipped in water. Do you remember what I said? When it is dipped in water inside a medium, what is angular fringe width? Theta dash is equal to theta by mu. Theta dash is equal to theta by mu. All right. Theta is what? 0.2. And mu is what? We are talking about water. 4 by 3. Get this guy to the numerator. 0.2 into 3 divided by 4. What is this? It is 0.6 by 4. What is it? 0.15 degree. Okay, 0.15 degree. Don't think that this is a simple question. It won't come. It is a difficult question, in fact. You know the shortcut now. It is easy. It is a previous board question. It came as a 2-mark question with calculations. Okay. So it could come in an MCQ anytime. It is implicitly given in the reader. Not directly given, implicitly mentioned in the reader. So it is important. Degree measurements. Angular fringe width is given by, inside water is given by, in air it is theta by d. Oh, no. Lambda by d. Inside water it is lambda by nd. That is theta by n. Got this all of you? Everyone? Can I have a response, please? Everyone. Okay, okay. Thank you, my dear students. Okay. Thank you very much. All right. Everyone, please. Right. So, a beam of electrons is used in YDSE experiment. A beam of electrons is used in YDSE. Okay. Actually, YDSE was done with sodium vapor light, sodium vapor lamp, or YDSE, Young's double slit experiment. What is YDSE? Young's double slit experiment. This was done for light, but later on it was done in iodine molecules. Even for electron diffraction was done. In 1984, YDSE was done in iodine molecules also, iodine molecules. All right, so that can happen with different cases, different sources. So they are asking what? The slit width is d. When the velocity of electron is increased, so this time instead of light, you are using what? You are using what? Beam of electrons. Where is it? Beam of electrons. Instead of light, in YDSE you had a source of light, but instead of light, this time around, you are using a beam of electrons to do YDSE. Okay, then they are saying about something. All right. Okay, so let us say, I'll tell you something. This is a multi-concept question. One concept comes from dual nature, another from wave optics. You know, we have learned de Broglie's equation as H by mv. Do you remember this? H by mv. Do you remember this? Can someone please tell me? Do you remember this or not? H by mv. Every moving particle, be it inanimate or not, it doesn't matter whether it has life or not. Okay, even objects without life can have a de Broglie wave. Only thing is that it should be moving. Okay, for example, when this pen moves, there is a wave associated with it. That is called de Broglie wave. De Broglie. We write it as de Broglie, we pronounce it as de Broglie. De Broglie wave or matter wave. That is also called matter wave. Okay, matter wave. Now they are saying what? Velocity of electron is increased. Look at that. Velocity is increased. Look at that. When velocity increases, tell me what? Denominator increases. So what will happen to lambda? Lambda will decrease. When lambda decreases, tell me what? They are asking about beta. Beta. What will happen to beta? Beta is lambda d by d. When lambda decreases, beta also decreases. So beta will decrease. So answer is option C. Fringe width decreases. It may appear to be a very simple question, but it is a hard question actually. Understood this, all of you? Everyone. Can I have a response, Hiba? All of you, everyone. Gabby, Rishabh, Martin, all of you. Sadiq, right. Okay. Yes, Mohammed, thank you. Right. So I can do it again. This is a multi-concept question, as I told you. You know, electron, you are doing interference experiment with beam of electrons. Instead of source of light, we have a beam of electron source. Okay. Now what? You know, lambda is given by H by mv. This is called de Broglie wave or matter wave. For an electron, lambda is given by H by mv. H is Planck's constant, m is mass of electron, v is velocity of electron. Lambda is wavelength, de Broglie wavelength. H is Planck's constant. You know what it is? M is mass of electron, v is velocity of electron. And they're saying what? Velocity of electron is increased. Velocity increases. So denominator increases. When denominator increases, what do you expect? This lambda will decrease. Lambda decreases. When lambda decreases, look at that. Beta and lambda are directly proportional. When lambda decreases, Beta, that will reflect in beta also. Beta decreases, so fringe width will decrease. Hope you got it, all of you. Tell me please, tell me please, tell me please. Moving on to diffraction now, or diffraction, whatever your teacher calls it. Okay, diffraction or diffraction. Okay, right. Okay, right. So let us see this in Fraunhofer diffraction. What is Fresnel? Okay, what is diffraction? Diffraction is again superposition of waves. Superposition of waves might result in a pattern called diffraction pattern. Okay, diffraction pattern. If diffraction is to occur, there is a condition. Do you know what it is? If diffraction is to occur, there is a condition. Do you know what it is? Do you know what it is? Wavelength of the wave must be almost comparable to size of the slit. Wavelength of the wave must be almost comparable to size of the slit. It shouldn't be greater than the slit size. It shouldn't be less than the slit size either. Okay, this is the condition for diffraction to occur. That is why sound waves can undergo diffraction much more easily than light waves. Why? Why? Because sound waves have large wavelength. Sound waves have, this is sound wave, large wavelength, right? Large wavelength, right? Sound waves have large wavelength. So, large slit size is okay. Large slit size is okay. Even the door, if it is open, I can hear someone talking from the other room. Why? Sound would bend around the corner and would reach my ears. But that doesn't happen so easily with light. No. Why? Light is small wavelength wave. Small wavelength. Look at the wavelength. This is called wavelength. Smaller the wavelength, smaller the slit size. Small slits are not easily available in nature. So diffraction is very difficult to observe with the light. Okay, that point is very important. The question is this: can sound waves undergo diffraction? Yes, sound waves can undergo diffraction. Basically, it is bending at an aperture, at a block. Light hits a block, it bends. It bends. Okay, right. So this is sound wave. Look at the sound wave. This is sound wave. Sound wave's wavelength. See the wavelength? This is sound wave's wavelength, okay? Look at that. Large wavelength, right? Large wavelength means what? Large wavelength means large slit is okay. Large slit is okay. That is easily available. That is why I said sound undergoes diffraction faster. You're going to see that question definitely day after tomorrow. Okay. Now, light, this is light. Poor guy. Light is what? Light has small wavelength. Is it okay for light to undergo diffraction? No. Had this been so easy for light, you would have seen someone sitting in the other room. You would have seen someone sitting in the other room, because light would bend around the corner and would reach your eyes. Okay, how do you see someone? How do I see the pen? Light falling on the pen comes off from the pen and falls on my eye. That is how I see the pen. That is how I have the perception of vision. All right. Okay, but I can't see someone in the other room. Why? I can't see someone in the other room. Why? Light falling on him has no chance of coming to my eyes, right? But if diffraction occurs so easily, that also could be possible, but that doesn't happen. Anyway, that is not our case now, where this is the condition for diffraction to occur. And I'm writing diffraction. We have only single slit diffraction. Single slit diffraction means, we can have, basically, interference and diffraction are the same thing. When you have two slits, you call it interference. Two slits, you call it interference. One slit or more than two slits, you call it diffraction. One slit or more than two slits, we call it diffraction. When I say more than two, how many do you expect? Can someone comment? Can someone comment? See, in interference, there are only two slits. Okay, Young's double slit experiment. Double slit experiment. Interference. Yes, Mohammed. Right. No, Martin. It is 25,000 slits. 25,000 slits. If I take a small piece of glass, that is called diffraction grating. A small piece of glass like this, a small piece of glass like this will have 25,000 cuts on it. 25,000 cuts made using diamond needles. Diamond needles. If you touch it, you will damage it. Even the fingerprints could damage it. All right. So that is called a diffraction grating. But fortunately, we don't have that in our syllabus. We have only single slit diffraction. Single slit diffraction. Okay, I'll give you an overview of single slit diffraction. This is what it is. Look at this. Single slit diffraction is this. You know, I have a single slit. On the screen, the central band will be a bright band. Bright band. Then next is dark band. Next is bright band. Next is dark band. Here it is bright, dark, bright, dark, bright, dark like this. Okay, bright, dark like this. The central band is always a bright band. Central band is, be it interference or diffraction, central band is always a bright band. This is called principal maximum. Principal maximum or zeroth maximum. Zeroth maximum. Okay, anyway, I'm going to write the condition. I'll tell you one more thing. In interference, this is how you draw the graph of intensity. All bands have equal brightness. All bright bands. Look at this. This is zeroth bright band. This is first bright band. This is second bright band. All have same height, right? Which means all have same intensity. Here you can take either phi or delta, phase difference or path difference. Phase difference or path difference. All bands are of equal brightness. All bright bands are of equal brightness in interference. But in diffraction, look at this, look at this, look at this. In diffraction, central band is the brightest of all. And as you go out, diffraction bands will decrease in intensity. Brightest band is central band. You can draw an envelope to these, right? That is exponential. Exponential intensity goes on decreasing. All right. So, tell me, you know, in interference, that is one of the major differences between interference and diffraction. In interference, all the bright bands are of equal brightness. All the dark bands are of equal darkness. Whereas in diffraction, central band is the brightest, and as you go outwards, brightness keeps decreasing. You have learned the reason for it in school classes. Okay. Anyway, the condition for maximum. I am writing the condition for maximum. This is the condition for maximum. 2 sine theta is equal to, d sine theta is equal to 2n plus 1 into lambda by 2. And condition for minimum, d sine theta is equal to n lambda. All right, where n can take any number value, integer values. All right, all of you guys understood? This is what you have to learn about diffraction. Let's straight away get to the questions. Tell me what? First question, you know, look at this. What is the condition for diffraction to happen? Again, what is the condition for diffraction to happen? You know, wavelength of the wave must be equal to or comparable to the size of the slit. Size of the slit. Then I told you condition for maximum. It is 2d sine theta is equal to 2n plus 1 into lambda by 2. Condition for minimum is d sine theta is equal to n lambda. All of you got this? Tell me if you have written this. All of you, everyone, please come on in the chat box. Tell me, comment box, everyone. Oh, what is this here? Tell me. Come on, guys, please. Okay, right. Okay, right. So anyway, you have written this. Hope you have written this. Let's get back to the question. Okay, so read the question. Fraunhofer diffraction. Do not worry if you see the name. There are two types of diffraction. Fresnel diffraction and Fraunhofer diffraction. But names do not matter at all. Fresnel diffraction and Fraunhofer diffraction. Okay, so we see only one word. Single slit. Single slit of width. The incident light of wavelength 5500 angstrom. So lambda is given 5500 angstrom. What is angstrom? Angstrom is 10 power minus 10. Angstrom is 10 power minus 10. All right. You know, the first minimum is observed. Look at that. First minimum. First what? First what? Could you please tell me? First what? First minimum. First minimum. Say it again. First minimum is observed at 30 degree. So I am writing the condition for minimum. What is the condition for minimum? D sine theta is equal to n lambda. D sine theta is equal to n lambda. D sine theta is equal to n lambda. What is it? D into sine 30. What is theta? Theta is given in the question. Theta is 30 degree. It's equal to what? First minimum. They say first minimum. That is 1 lambda. Lambda is given 5500 into 10 power minus 10. What is this, guy? Sine 30 is actually 1 by 2. 1 by 2. Get that 2 to the right hand side. You got D now. Let that 2 go to the right hand side. 2 into 5500. That is 11,000 into 10 power minus 10 meters. Okay, so I got D here. I'm going to use this in the second case. What is the question? First secondary maximum. First maximum. First maximum. First maximum's condition is what? First maximum's condition is what? D sine theta is equal to, maximum's condition is what? D sine theta is equal to 2n plus 1 into lambda by 2. Say it again, say it again. D sine theta is equal to 2n plus 1 lambda by 2. Tell me guys, I can put it back here. What is D value? 11,000 into 10 power minus 10 into sine theta. Sine theta. What are you talking about? Look at that. They are asking first secondary maximum. First maximum. First maximum means n is equal to 1. N is equal to 1, isn't it? Isn't it? N is equal to 1, 2 into 1, 2. 2 plus 1, 2 into 1, 2. 2 plus 1, 3. 3 lambda by 2. 3 into lambda 5500 into 10 power minus 10 by 2. I don't have space here, so I'm just cutting it off, and let me see where I can write. 5500 and this are cut. 10 raised to minus 10, 10 raised to minus 10 cut. 5500 and 11,000, it is 2. So tell me what I get. Sine theta alone is on the left side. Sine theta, I got sine theta here. What is sine theta? Then I have a 2 going to that side. Oh, 2 coming to the right side. 3 is already there. So that makes it 3 divided by 4. Or theta will be what? Come on guys. Sine inverse 3 by 4. Sine inverse 3 by 4. Yes, it is there in the answer options. Right. All of you understood this? Sine inverse 3 by 4. Got this? Everyone. So did you understand how I did it? You know, I used the condition for diffraction minimum. What is diffraction minimum? D sine theta is equal to n lambda. They say it is first minimum. So put n is equal to 1 to get the value of D. Then put it back into the second condition. First maximum. What is maximum's condition? D sine theta is equal to 2n plus 1 into lambda by 2. Okay, so you put the values, eventually you're getting what? Sine theta is equal to 3, then 2 goes over there, that makes it 4, 3 by 4. So that gets you what? 3 by 4. Sine theta is 3 by 4, theta is sine inverse 3 by 4. Tell me if you got the answer. Answer is option C. 4 more to go. Make it quick. I'll maybe take 5 more minutes to finish it off. If we can respond fast, you know, Ravi sir is already waiting with a session on ray optics. That's also equally important. Now, you're definitely going to get the questions if you attend that session alone, right? That is our promise. You know, we have always kept our promises, all right? Okay. We are all here to help you. We are all with you. Do not worry about anything. Okay. We are going to face this together. We are in this together, right? Do not worry, all right? Do not lose heart. Okay, right. Yeah, thank you. Now moving to the next question. Yellow light in single slit diffraction experiment. Look at this. Yellow light is, okay fine. Yellow light in single slit experiment with a slit width 0.6 millimeter. If yellow light is replaced with X-rays, you know, yellow light is replaced with X-rays. What happens if yellow is replaced with X-rays? What happens? You know, in diffraction, we find the width of central band as 2 lambda d by d. Width of central band as 2 lambda d by d. In diffraction, width of central band alone. In interference, all the bands irrespective of whether it is a dark band or a bright band, width is the same. But here it is not so. Tell me, in diffraction, central band has maximum width. Central band has maximum width. It is 2 lambda d by d. Now tell me what happens when you go from yellow to X-ray. They're saying what? Yellow is replaced with X-ray. X-ray, you check it out on electromagnetic spectrum. Check it out on electromagnetic spectrum. You will see that when you go from yellow to X-ray, wavelength decreases. Wavelength decreases. So when wavelength decreases, beta decreases. Am I correct? See, I got you there. It is wrong. It is wrong. Because if you check internet for solutions, that is what you will see. But that is absolutely wrong. Because wavelength is so small that diffraction won't occur. Why? Because if diffraction is to occur, I told you beforehand, look at this. Lambda should be comparable to the slit size. Lambda should be comparable to the slit size. But here what happens is, when you replace yellow with X-rays, X-rays wavelength is so small that diffraction will not occur. Diffraction will not occur. So the answer is option B. No diffraction pattern. No diffraction pattern. And as I told you, if you go to internet for solutions, you might see different answers, but this is the correct one. Got it? This is the correct one. Diffraction will not occur. If diffraction is to happen with X-rays, you use crystals. Crystals. There is a setup called crystal diffraction. Crystal lattices will be used, but that is far beyond the scope of your syllabus. I'm not intending to do that now. It is not needed either. But just know it's a standalone question. It is a unique question. It has high chance of coming in an examination because they might get you in a trap here. They might get you in a trap here. Got it? Do not fall in the trap. Diffraction is never going to occur. All right. Hope you got it. Shall we move to the next one now? Make it quick. Okay. Now one more question I'll do. Okay, right. Okay, right. This is again a previous question. Two slits are at a distance of 1 mm are illuminated by light of wavelength. I'll make it very quick. Light of wavelength, lambda is 6.5 into 10 raised to minus 7. So lambda is given. Lambda is how much? 6.5 into 10 power minus 7 meters. Then interference fringes are observed on a screen placed at a distance of 1 meter. So distance is how much? Distance is how much? 1 meter. Distance between third dark and fifth bright. Third dark and fifth bright. Look at this. Look at this. Now this is the screen center. Screen center. So distance to third dark. Okay. Distance to fifth bright. Okay. So they are asking for which distance now? This distance now. This distance now. I can call it delta x. I can call it delta x. How do you find it? Distance from center. This is center of the screen. Center of the screen. From distance to the distance from center of the screen to the nth bright band is given by what? Fifth bright band. It is given by 5 lambda d by d. Do you remember that equation? Distance to the nth bright band is given by n lambda d by d. Say it again, n lambda d by d. Say it again, n lambda d by d. Distance to the nth bright band is n lambda d by d. Come on guys, it is 5 lambda d by d. Now, what about distance to third dark? Distance to the dark band is given by 2n minus 1. 2n minus 1. n is 3. Third band, right? 2n minus 1 into lambda d by 2d, which is what? 2 into 3, 6. 6 minus 1, 5. So it is 5 lambda d divided by 2d. So now that I got both distance to fifth bright, distance to third dark, I need to find the distance between them. I need to find the distance between them. How am I finding it? How am I finding it? Delta x is equal to distance from here to here. It is x5b. Distance from here to here, x3d. So what is this distance? It is delta x, right? Can someone tell me please? Right. Yes, yes, yes. Tell me. x5b minus x3d. So tell me what you're going to get now. This is 5 lambda d by d. 5 lambda d by d minus this is 5 lambda d by 2d. Now you take the difference. You take, I don't have time, so I'm not simplifying it. I'll just give you the hint. 5 lambda d by 2d. You substitute lambda given in the question. Capital letter D given in the question. Small letter d, forgot to give you. I'm really sorry. Forgot to give you. You know the value of this is small letter d is 1 mm if I remember correctly. Anyway, when you try that out, you will get the answer as 1.63 millimeters. 1.63. I still remember the value. It's a previous board question. Coincidentally, it is a previous JE question also. All right. JE question also, exactly same data. But remember, in boards, it won't come as an MCQ. It will come in a 2-mark question. All right. It will come in a 2-mark question. So how to find it? Distance to fifth bright, distance to third dark, then distance between them. It is distance to fifth bright minus distance to third dark. Then substitute the values, you will get the final answer. Hope you got it, all of you. Can I take 2 more minutes to finish it off? 2 more minutes to finish it off so that Rafi sir can... Is it okay, everyone? Continue with this. Okay, right. Maybe like 2 more questions. Oh, right. So I'll do this question. The slits in a Young's double slit experiment have equal widths and the source is placed symmetrically related to the slits. The intensity at central fringe is I0. Intensity at central fringe. Intensity at central fringe is what? Intensity at central fringe is also called I max, because central band is always what? Come on, central band is always what? Central band is always maximum. I told you, be it interference or diffraction, central band is always a bright band. Central band is a maximum, right? Central band is a maximum. So I central is I max. How to find I max? Root of IA plus root of IB the whole square. I must have said 100 times now. Root IA plus root IB the whole square. What is it? 2 root I the whole square. What is it? 1 root I plus 1 root I. 2 root I, right? That is 2 square. That is 4I. Okay, I central is, I got I central. I central, they call it I0. I0 is what? I central is I0. Central fringes is I0. I0 is 4I. Then they are saying what? You're going to close one of the slits. Look at that. Is that the question? If one of the slits is closed, tell me. If one of the slits is closed, tell me, what is your prediction? One of the slits is closed, interference won't happen anymore. Interference won't happen anymore. Then what? Only this light will come. Only I will come. Only second eye won't come. There won't be interference. Second eye won't come. So tell me, what is the intensity now? Only one intensity. So they're asking you to find the ratio, it seems, right? Yes. So I'm going to take the ratio. I dash divided by I0 is equal to I divided by 4 times I. I and I are cut. Get this to right hand side. I dash is equal to I0 by 4. That is again a typical question, a standalone question, very important one. I repeat that point one more time. First case, they say what? In Young's experiment, you know, they have equal width. Equal width means both are II. Both are II. Okay, right. And the source is placed, whatever it is. No, forget about that. The intensity at the central fringe is I0. Central fringe is always a maximum. I central is I maximum. I maximum is root I plus root I the whole square, which is 2 root I the whole square, which is 4 times I. And what about closing one slit? If you close one slit, interference stops. Interference won't be there anymore. You get what? Only one light. Only one light. That is I. So the new intensity is I. Then take the ratio. I0 by I dash will be I by 4I. That's going to give you I0 by 4. Hope you got it. The last question, I'll wind up. Okay? All of you got this? Okay, right. I'll just give you the hint for this. It's an easy question. You can try this as a homework. A mixture of light. If you don't get it, get back to the office number. We will give you the solution. Or you can just Google to get the solutions, okay? Right. A mixture of light consisting of wavelength of 590 nanometers and an unknown wavelength. So second wavelength is lambda 2. Okay, illuminates a Young's double slit and gives rise to two overlapping patterns. Central maximum of both lights coincide. Central maximum of both lights coincide. So this is the setup. Look at this. There are two lights. It's a bichromatic light. Bichromatic, not monochromatic anymore. Mono means single, chromo means color. Mono means single, chromo means color. One of the conditions for YDSC is monochromaticity. Monochromaticity. They use sodium vapor lamp in your school laboratory. They can't afford to have laser, red laser. Red laser is perfectly monochromatic. Perfectly monochromatic. Anyway, this is like bichromatic light. Okay. Further, it is observed that third bright fringe of known light coincides with fourth bright fringe of unknown light. Third bright fringe of non-light, first wavelength. I can call it simply 1. Third bright fringe of first light coincides with fourth bright fringe of second light. Coinciding means what? They fall at the same location. Coinciding means what? Coinciding means what? Coinciding means what? Coinciding means they fall at the same location. They fall at the same location. All right. Which means what? Distance from center to that point is the same. Distance from center to that point is the same for both lights, for both patterns. So tell me, this is the condition given. Distance. Further, it is observed that third bright fringe of non-light. Non-light means the wavelength which you know coincides with fourth bright fringe of unknown light. So distance to the third bright fringe of first light is equal to distance to the fourth bright fringe of second light. Distance to the third bright fringe of first light is equal to distance to the fourth bright fringe of second light. So how do you do it? 3 lambda 1 d by d. Distance to nth bright band, n lambda d by d. Say it again. Distance to nth bright band, n lambda d by d, n lambda d by d, n lambda d by d. Distance to the nth dark band, 4 lambda 2d divided by d. D and D are cut, D and D are cut. You can solve it, get the answer, and get back to us with a comment. And I'm signing off for the time being. Ravi sir will take off from here. And do not worry about the exam. We are all together in this. We are here to help you. Okay, do not worry. Now this is just another exam, a small exam at a particular time of your life. There are more things to come, better things to come. Do not lose heart over anything. All right, just be bold. Just be bold. You're going to fight it out. Okay, just be the bold guys you've been bold all along, and you're going to be the same throughout. Okay, so wish you the very best. We will see you tomorrow. Before that, Ravi sir will take ray optics now. Stay till the end. This session is also very, very important. Very important questions will come now. So see you next class. Bye. Thank you.
Yes, everyone. Good evening, all. Good evening, everyone. Can I start? Good evening. You guys are ready? You guys back after the wave optic session? Comment on the chat box, please. You guys are ready? Can I start now? Yes, Martin. Yes, everyone. Make it fast. Yes. Can you hear me properly? Yes, Gayatri. I can start, right? Yes, Satik, Martin, Steve. Yes, all. Hopefully, all are with me. Yes. Okay, everyone. Hopefully, perfectly the things are going on, the live sessions. Let me start then. Ray optics. About the ray optics, it is playing major role in 12th standard board paper, right? Ray optics, you can see a lot of questions. It's a comparatively high weightage chapters. The final moment, I am gonna give you some important question discussion from ray optics, most expectable questions. Okay, somewhat MCQ, somewhat theoretical questions, etc. I made like this descriptive numericals. All right, so let's start the session then. Look at the first question, all of you. Read the first question. Everyone, please read the first question. More chance to come this pattern. Lens makers formula based question. Read it carefully. Focal length of take your book and pen. Okay, hopefully with you now. Come back and do it. Okay. Yes, Muhammad. Yeah, Kalyan. Focal length of a convex lens of a refractive index is 1.5 is 2 centimeter. The focal length of the lens when it is immersed in a liquid of refractive index 1.25 will be lens in air, lens in liquid, or lens in some medium. It's a very famous question. So do you know the lens maker's formula? We are using here lens maker's formula. Case number 1. Case number 1 means what? When the lens is in air. When the lens is in air, okay? This is a lens in air. When lens in air, what will be the focal length expression? Lens maker's formula, tell me all. 1 by f is equal to n2 by n1 minus 1 into 1 by r1 minus 1 by r2. This is the lens maker's formula, right? Lens maker's formula. So let me call this focal length. This focal length in air is how much? Which is given 2 centimeter. So 1 by 2 is equal to, I am not converting into centimeter because options are already in centimeter. So we don't want to convert. Okay. So first case, what N2 means what? Can you repeat what is N2 stands for here? F means focal length. N2 means, refractive index of lens. What is N2? Refractive index of lens. N1 means what? Surrounding medium refractive, where the lens is kept. So this is basically what? Refractive index of lens. Those students who forgot about this formula repeatedly learn. It's a very important formula. Refractive index of lens and refractive index of what? Surrounding. That means where this lens kept, that matter. Okay, R1 and R2 are the radius of the two sides of a convex and or concave lens, whatever may be the lens you are talking. Okay, so here, first case, surrounding is what? Air. So lens refractive index how much? 1.5. Air refractive is how much? 1. So we can ignore N1 first case. Minus 1 into radius and all not mentioned. You can keep as it is 1 by R1 minus 1 by R2, equation number 1. All right. Now come to the case 2. Now come to the case 2, all of you. Now come to the case 2. Okay, case 2. What's case 2 saying? When the lens is kept in a medium. So when lens in medium, surrounding thing is changing. Surrounding thing is changing now. So what is the lens focal length when it is in medium? Come on. Yeah, it will be 1 by f equal to N2. What's N2? Refractive index of lens. How much it is? Is it changing? No. What is changing here? Surrounding is changing. What surrounding? Where you are going to keep this one? Surrounding as a medium 1.25. 1.25 is the refractive index. Minus 1 into radius, not changing, right? Whenever you are keeping in air or medium, radius are not changing. Radius of the sides of a lens are not changing. So only change happen here, surrounding medium. We need to find this f. Let's call this equation number 2. You can divide then. You guys can divide equation 1 and 2. Then you will get the answer. Can you divide that two equations? Equation 1 by 2. If you divide, equation 1 by 2, if you divide, 1 by 2 divided by 1 by f. Okay, what you will get? The left hand side, 1 by 2 divided by 1 by f means take the reciprocal. When you take the reciprocal of 1 by f, what you will get? F by 1, right? I am dividing these two ratio. Then on the other side, when you divide 1 by 2, what is left here? If you divide these two terms, 1 by r1 minus 1 by r2 are both exist, so it can cancel out each other. So what is left then? 1.5 minus 1 divided by 1.5 by 1.25. Okay. So for handling it is easy. Can you do that calculations? Yeah, can you do that calculations? It comes to be how much? 1.5 by 1.25. Anyone can comment what this ratio value equal to? 1.5 by Kalyan. Comment Kalyan. What's the answer? 1.5 by 1.25. How much you are getting? I think it is 1.2, right, Kalyan? 1.2, right? Yes. 1.2, I think. 1.2 minus 1. 1.2 minus 1, I think. Okay, check it. So this ratio. So you will get what? F by 2 is equal to this side. F by 2 is equal to this become what? 0.5 divided by 0.2, which comes to be how much? 5 by 2. Then you can cancel. These two terms. So you will get what? F is equal to 5 centimeter. Focal length is equal to 5 centimeter. Did you get that? F is equal to 5 centimeter. Easy question only. Everybody can do this. Easy pattern. Okay, easy pattern. When lens is placed in the air, first you should aware of the lens maker's formula. If any kids forget about this formula, remember the equations, understand each letters involved here. What is N2? Refractive index of lens. N1 means what? Surrounding. Alright, if you substitute those, you will get. First case is in air, so N1 will be 1. Second case in liquid. How much is the value of the medium refractive index here? It is given in the question 1.25. If you substitute, you will get two equations. Then that two equations, if you divide, you can find this F. F you will get 5 centimeter. Are you okay? Are you got this welcome question? Important, okay, I'm repeating this, an important pattern. Lens maker's formula. Usually asking in examinations. Hopefully you got this content, right? Are you okay with this one? Perfectly, all right. Can you comment on the chat box properly all? Yes, everyone. Yes. Okay, then let me move to the next question all. Look at the next question. A small bulb. It's another very famous question, okay? Another very famous question, this one. Bulb placed in a pool, okay? So a small bulb is placed at the bottom of a tank containing water. Depth is how much? Water depth is how much? Look at this. Water depth is, read the question carefully, √7 meter. The refractive index of the water is given how much? 4 by 3. Refractive index given 4 by 3. The area of the surface of the water through which light from the bulb can emerge out is given by x into pi meter square. Then what is the value of x? That's the question. It is one of the very important pattern. NCERT you can see, inside the NCERT you can see example 1 solved question and exercise question 1 is another there, and this another third type of question based on the same topic. It's a very commonly repeating type. It's based on TIR. Look at this. A small bulb. Let me draw here. A small bulb which is placed at the bottom of a tank. Then how will be the light comes from here? So the light comes from here. You know the concept. Here, look at this incident ray and all making lesser angles. So imagine it's a source of light. Bulb is here. And here also light is come to this side also. What will happen to that light rays? Yeah, that light ray, undergo refractions. Okay, here all undergo refraction. But when the angle of incidence comes to be critical angle, then what will happen to the light ray? It grazes the surface, right? It grazes the surface. What happened to the ray beyond it? It will reflected back. TIR will happen. You know that. I'm not taking that kind of depth way because you guys already learned this. Okay, and here this will be the area. This will be the area of light in which it comes out, right? It comes out. This. Here, this incident rays and all, it can emerges out. Why it is emerging out? Because angle of incidence is what? Lesser than C. Here angle of incidence equal to C. It's grazes. Here angle of incidence. What about this ray? Angle of incidence is more than C. TIR here. But here not TIR. Angle of incidence is what? Lesser. So all the light ray through this circular faces emerges out. Remember, it's a very famous pattern. When a small bulb is placed at the bottom of a pool, then light ray emerges from the pool will be what? It will be circular shape. It will be circular shape. Remember that concept? And what will be this angle? This angle is called what? Critical angle. Critical angle. Okay, come back then. Yeah, that's a very famous question. You remember that concept. In case you not learned, please revise that topic particularly. Look here, all of you, once again. Let me come back to this question. There's a source of light at the bottom. Source of light at the bottom. I told you, in a swimming pool, a bulb is kept. In case you are not remember the all concept, at least remember this point. Then, if you keep like a bulb at the bottom of a tank, then what is the area of the surface in which light comes? It's a circular face. Okay, circular way the light rays comes out. So what will be the area of the circle? That's what asking, right? Yeah, here area of circle is given. So we have to find the x value. So see this one. This is the radius of the circle. Let's call that is r. And this one, what this angle is called? A critical angle, because this angle is what? Critical angle. And what about the depth of this? What about the depth of this? Depth of this is √7, right? Root 7 meter. And how will you find this? Yeah, first you should find tan C from that triangle. Tan C. What's the tan of this angle? Tell me. Opposite side divided by adjacent side. What's the opposite side of this? R. R divided by adjacent side. What's that? √7. R by √7. So from here, R by √7. You got tan C, right? You can call this equation number 1. Okay. We have to make equation for R. Equation for R. R is equal to what then? First of all, R is equal to √7 into tan C. What is R? Radius. R is what? Radius. You can call this equation number 1. Then can we find tan C? Yes, we can find tan C. How? The refractive index and critical angle relation. N equal to 1 by sin C. What is n value here? N means refractive index. What's refractive index? 4 by 3. Refractive index is 4 by 3, which is equal to 1 by sin C. It is equal to 1 by sin C. From here, I can find what? Sin C. Sin C is how much? Sin C will be reciprocal of this. It will be 3 by 4. Sin C 3 by 4. I have sin C. I need tan C. Then I will get what? Radius. Once I got radius, how can I find the area? Pi r square. Right. So we need to make tan C value from sin C. I will tell you the idea how to find tan C, any trigonometric function from like a triangle form. You can make a triangle form. Look at this. If suppose in an angle in which this angle is C, then what do you mean sin C? Opposite side is 3, adjacent hypotenuse is what? 4. Opposite side is 3, hypotenuse is 4. Okay, then can you find this side? Yes, we can find that side, right? How? Yeah, hypotenuse square, that is 4 square. 4 square is how much? 16. Minus height square, how much is 9? If you solve this, how much you will get? √7. That you will get √7. Then can you say what is tan C? Yeah, tan C we can find from this, no? Tan C will be what? Opposite side divided by adjacent side. 3 by √7. So we got tan C. Understood this? So from any trigonometry, we can find another trigonometric function by making this kind of triangles. Okay, from a one trigonometric function, we have two sides of a triangle we can find. Then the third side, you can find by Pythagoras theorem. Once you got the third side, you can define all other trigonometric function, right? So how much tan C? Let's substitute then. Tan C you can substitute here. What you will get? Tell me. √7 into 3 by √7. Cancel out each other. So we will get what? R is equal to 3 meter. Okay, what will you get? R is equal to 3 meter. R is equal to 3 meter. But what is given in the question? Area is given as x into pi. Area is given as x into pi. Let me do that on another slide. Focus on this. Area of a circle. How will you find pi r square? Pi r square. Which is given here x into pi, right? X into pi. So therefore, we have to find that x value. This pi get cancelled. What's the r value which you got? R value 3, right? R value 3. Substitute. R is 3, so 3 square is equal to x. That means x is equal to 9. X equal to 9 is the answer. Did you get the? Yes, Hiba. X equal to 9 is the right answer. X equal to 9 is the right answer. So 9 is the right answer. Very, very important question, this pattern. It's a very famous pattern. Hopefully all okay with this. Yes, Muhammad, it is C. Oh, great. Correct only. Good, good, good. Understood, right? It is clear to everyone? Yes. Very important question. Remember, when a bulb is placed at the bottom of the pool, then what is the light ray emerges from the pool? It will be circular in shape. How will you find the radius of the circle? You can find tan C from here, R by height. Okay, so R by height you can find the radius. Once you got the radius, how to find area? Pi R square. So, but here the problem, tan C not directly available. But you know, sin C have a relation to the refractive index. From that sin C, you can find tan C, then substitute. So you will get what? Radius. Once you got the radius, you can find the area. Okay, here the question will be little different pattern. The area is given, then asking for x. They can ask, you know, any convert. They can convert into different pattern the questions. The concept is same only. Okay, hopefully you all okay with this one. Can I go to the next question? Hello all, can I go to the next question then? Yes, yes. Let me go to the next question. Yes, everyone. Look here, the next important pattern, okay? Next important pattern of questions. Listen. The critical angle for a denser medium, denser to rarer interface is how much? It's also expectable question for the board. Critical angle is given how much? 45 degree. The speed of light in a rarer medium is 3 into 10 raised to 8. Can you say what is that? 3 into 10 raised to 8? Vacuum or air speed, right? Speed of light in air. What is the speed of light in denser medium? That's what asking. What is the speed of light? It's easy question only, but this is a 2 mark. Don't miss this pattern. Look at this. Speed of light in any medium. How will you find? C by N. What is N stands for? Refractive index. C means what? Speed of light in vacuum. So here C is how much? 3 into 10 raised to 8. But refractive index is not given. But we can find the refractive index of a medium. They're given the critical angle. So refractive index, how will you find? 1 by sin C, right? 1 by sin C. So therefore refractive index 1 by sin C. Sin C is how much here? C is 45, right? C is 45. C is 45. 1 by sin 45 is how much? It become root 2, right? Root 2. Sin 45 1 by root 2. So root 2 will goes up. So we will get 3 by root 2. 3 by root 2. And you guys know, right? What is 1 by root 2 value? We learned in chapter AC. We learned chapter AC. What's the 1 by root 2 value? It's very famous, right? VRMS is equal to we learned in AC chapter that value. 1 by root 2 is how much? 0.707 of V0. 1 by root 2 value how much? 1 by root 2 value 0.707. That's a useful result. So 1 by root 2 you can write what? 0.707. So 3 into 0.707 into 10 raised to 8. If you solve this, yeah, it's become 2 point something. Which option? Option B. Look at this. 2.12 into 10 raised to 8 meter per second. Okay, that will be the final answer. Is also easy question only. Remember, speed of light in any medium, how will you find? C by N. How will you find N? Suppose it is not given. If critical angle given, N equal to 1 by sin C. Substitute. Substitution only. Easy pattern. Don't miss. Okay. 2 mark expectable for the board content. Yes, I hope it is clear to you. Can I go to the next question? All are board pattern, okay? All are board pattern. So it's very useful. I am expecting a question will come from these particular areas which we are talking now. Yes, right? Yes, everyone. Let me go to the next question then. Yeah. This is the previous year CBSE questions, okay? 2 times. So there are 2 type of questions will be there. One, this one, and you know, one of the similar pattern is here also. There are 2 type of questions. It came in, I took this one from the CBSE past papers. I took this one from CBSE past papers. Very important. Focus on this, everyone. Can you read these questions? You guys can read this, okay? Please read carefully. Please read carefully this question. Don't worry, I will help you how to solve this. A converging beam. Yeah, there is a converging beam of light. Look at that diagram. Look at that diagram. A converging beam of light. A converging beam of light like this is incidenting on a surface. What kind of surface this one? Converges. A converging beam of light traveling in air. Where from coming? Air. Air converges at point P. Where they are going to converge is point P. Where the point P as shown in the figure. When the glass of a sphere of refractive index. So the refractive index of this one is given how much that? 1.5, which is given in the question. Calculate the position of image. Where will be the image will form? When a light is come so, where will be the final image will form? Okay, this light is come from where? Some object. Then where will be the image we can see while inside the sphere or something? Yeah, that's what the question asking. Also draw the ray diagram for the image formed given the transverse section of the leaf. Identify the layer of, sorry, that's wrong. That's wrong, okay? It's biology comes. Here only, okay, sorry for it. Yes. This much part only physics, sorry. There's a technical error, leave it about it. Come on. So here you want to draw the ray diagram. Okay, you want to draw the ray diagram as well as you want to find the position of image. All right. So what do you feel? Which equation we will use here? Are you scared about this question? Yeah, we can break this question also. Look here. What type of surface you are seeing here? Tell me what type of surface you are seeing here. Are you seeing a curved surface? Yes, you are seeing a curved surface, right? So here light is refracting through a curved surface. It is not a like plain surface. It's what? Curved surface. You guys learned na curved surface formula. Can you say what will be the curved surface formulas you learn? When a light is incidenting on a curved surface like this, it's not a plain surface. Plain surface refraction you learned already. So here light is incidenting where? Light is incidenting on a curved surface. Could you tell that formula which you learned? There are two cases, right? When light is moving from rarer to denser in curved surface, the formula become N2 by V minus N1 by U is equal to N2 minus N1 upon R, right? Is the formula. When light is moving from rarer to denser on a curved surface, what's the formula? Yeah, let's learn this formula. I hope you guys are already prepared the derivation. Derivation is also important. Then only you can learn the derivation of lens maker's formula, etc. What's the formula? N2 by V minus N1 by U is equal to N2 minus N1 upon R. Okay, what will be the change when the light is going from denser to rarer? That means inside the surface is like a what we call rarer. Light is outside medium is denser. Then what will happen? What is the change? You guys know, right? N1 and N2 just interchange. That means N2 position, right N1. Okay, rest of the all things are same. N1 position, right N2. Okay, that's the things we gonna want to change when suppose it is denser to rarer. Understood, right? So these are the two formula. Don't forget, when a light is incident on a curve, it's a previous CBSE asked question. That's what I am going to teach you. When light is incidenting to the curved surface, rarer to denser, formula will be this. Denser to rarer, formula will be this. All right. Let's come to this question then. Where the light is incidenting from here? Yeah, light is incidenting from air to glass. Rarer to denser. Rarer to denser. What's the formula? Which formula will you use? Tell me. N2 by V minus N1 by U equal to N2 minus N1 upon R. Could you tell what is N2 stands for? What is N2 stands for? N2 stands for refractive index of the medium, the curved surface. Refractive index of the medium. Refractive index of the medium. N1 means what? Refractive index of the surrounding. Refractive index of surrounding medium. Refractive index of surrounding. All right. V means what? Image distance. U means what? Object distance. R means what? Radius. R means radius. Okay, important question. This is a past, the last year CBSE board question. Come on here. Here light is moving from air to glass. That's why I used this formula. All right. In case if it is opposite, that question is coming. That question is coming. Okay. Wait. There are two questions I set based on that. So here, come back. N2 means what? Refractance of medium. How much refractance of medium? Could you read that? Look at this. It is 1.5. Refractance of medium is 1.5. What's the question asking? Find the position of image. V required to find. Then V is the unknown here. And what is N1? Surrounding is what? Did you read the question carefully? Surrounding is air. What's the refractance of air? 1. Refractive index of air is 1. What is the U value here? That's a twist. Look at this. The U value is very important. Yeah, U value is very important. Here you are breaking the concept, okay? Look at this. What is the object distance here? Sir, there are two types of objects are there. Focus on this. There are two types of objects are there. This might be an additional information for you like in ray optics. Look at this. If suppose before the optical phenomenon, light is appeared to come from a point before the optical phenomenon means what? Reflection or refraction. Before the optical phenomenon, light is actually coming from a point, then that is what we call it as real object. Okay, remember this, all of you. There are two types of object we have: real object and virtual object. Okay, virtual object. This is a case question for virtual object situations. Before the optical phenomenon, light is actually come from a point. Imagine like some mirror or something is present. Then what will happen? The light, it undergo reflection, right? So before the optical phenomenon, light actually come from a point, then that is what we call the real object. What's another possibility? Virtual object. What's the meaning of virtual object? See this example. Before the optical phenomenon, did you feel the light rays are actually come from a point? No, it's actually appear to meet, right? This case, you can see what? The light ray is appear to meet. Look at this. There are two stories can come. Light is actually appear to meet here. It's actually come from a point. Before the optical phenomenon, light is actually come from a point is called what? Real object. Appear to come is called what? Virtual object. Virtual object. Hopefully that's clear to you. Okay, you can add on this point. Okay, yes. So here is the case where, look at this. What do you feel this light ray? What do you feel this light ray? Is it actually come from a point? No, it's appeared to come towards a point. So what type of object is one? It is a virtual object. It's a virtual object. And what is the object distance here? What's the object distance here? Look at this. This is the object distance. Distance from this particular point to the meeting point, appear to meeting point, somewhere here. How much it is? That is 20 centimeter. Is it plus or minus? It is plus. You will be plus here because the object distance is, towards the right side. Along the incident ray you are measuring, not left side. Usually the left side and all what? Negative. Here it is towards the right side. So it will be what? Positive. How much it is? Positive 20. Alright. It is equal to, come on. Then N2. N2 means what? Refractive index of the medium. How much it is? 1.5 minus 1 upon the radius. Look at this. What's the radius? Its diameter is 10. Then what will be the radius? 5. There is a chance to make the mistake, okay? So very careful. Given thing is diameter, make it into half for radius. Then substitute. Now you guys can solve this. You will get the position of image. You will get the position of image. Come on. 1 by 1.5 minus V by V minus 1 by 20 equal to, if you solve this, how much you will get? 1.5 minus 1, 0.5. And 0.5 means what? 1 by 2. So if you solve that, you will get it's 1 by 10. You will get 1 by 10. Could you solve then correctly? How much you getting? Yeah, 1.5 by V, I can write what? 3 by 2 V, right? Because 3 by 2 is 1.5. Minus, or I can bring the minus 1 by 20 to that side. I will get plus 1 by 20 and plus 1 by 10. And you guys can do the calculation and you can comment your answer. What's the V value which you are getting? 3 by 2V is equal to 3 by, if you multiply 2 denominator, you will get denominator as 20. So you will get 3 by 20, right? So once you solve this, are you getting V as 10 centimeter? Yes or no? V as 10 centimeter you got? Correct, Christopher. Yes. V as 10 centimeter. Which means what? What is the meaning of 10 centimeter? Did you guys all note this point? Yeah, what's the meaning of V 10 centimeter? Where's 10 centimeter? Do you focus that? Yeah, 10 centimeters are, look here, 10 centimeter, okay. 10 centimeter means, look here, the final image is formed 10 centimeter from this pole means where? Here. That is center of the second curved surface. Here will be the image will form. So we got the position of image plus now it's on the right side. Now we want to draw what? The ray diagram. Ray diagram. Are you all completed the calculation? Let me show how to draw the ray diagram then. Yes, focus on this, okay? Focus on this. It's a different pattern. You have to remember this question also. Let me show you that. The diagram. There is a sphere we have. And this is the principal axis, where the light ray comes here, where from the light ray comes? The light rays come from this particular side. Alright, they are coming like this. And what will happen here? It undergo refraction. Look at this. So how to draw the ray diagrams properly? Look here, this appeared to. Let me draw this, wait. This is the normal, right? This is a normal. How to draw normal? Normal means what? Meet that point with the center. That's what normal. Where the light ray going from here? Air to glass. So bend towards the normal. How it bend? It bent towards the normal. It bent towards the normal. This way they will bend. Okay, from the actual line, it bent little close. It bent little close. Okay, you can make the proper diagram. It bends slightly like this. So you can see that where the final image is forming, where the light rays are meeting, they are meeting here. That image distance, what we call image distance, is 10 centimeter. Image distance is 10 centimeter. Did you get the ray diagram? Did you get the ray diagram? Okay, here light is going from air to glass. So it bent towards the normal. So automatically what happened? That light ray converged a little more. So meeting at this place. So good question. Previous board question. Okay, curved surface formula based questions. Hopefully you okay with this. So let me move to the next question. Yes, right. You guys are. I hope you guys are a little serious. So we want to discuss more questions today. Yes. Let's move to the ray optics. Very important ray optics questions. Look on the next question, all of you. Look on the next questions. Come on. Look at the next question. Come on, everyone. Look on the next question. A point object. Come on, look at this question, okay? Can you read this? Similar way. Whatever you see the before question, same approach. Can you break this question? Can you break this question? Let's break. The previous question, sir, why you said two similar type question? A slight difference is there. Here, you can see that. Read the questions. We are doing, minimum number of questions from the ray optics. You can make what? We are investing less time to get more mark. So that quality questions are set here. So we can discuss this particular question. Did you complete the reading? Okay. Look at this. A point O. Where is the point O marked here? Look at this sphere. This is the place where the point O marked. Point O marked here. The point O is marked there. On the surface of the glass sphere, what's the diameter? 20 centimeter. Diameter is 20 centimeter. Dia is 20 centimeter. Viewed through a glass. It's a glass. Position directly opposite. Where from it's looking? Opposite position. Opposite position. Leave it about that. If the refractive index of the glass is 1.5, the medium refractive is how much? 1.5. And the position of the final image, where the final image will form. Where will be the final image form? Draw the ray diagram. That's what the question asking. Look at this. Where is the object? All of you, where is the object? Object inside. So where from the light is coming now? Look at this. Its light is coming from denser to rarer. That's why this question is different. Previous question is what? Rarer to denser. This is now what? Denser to rarer. Object is here, observer is here. So light is moving from inside the glass to outside. So denser to rarer. So denser to rarer. Things changed. So you want to use opposite formula. Opposite formula here. What's that formula? Could you tell? N2 by V. That's the first formula. N2 place you should write what? N1. So N1 by V minus N2 by V minus N1 by U, right? Then here it is what? N2 by U, and N2 minus N1 by R is the actual formula. So N1 minus N2 by R. I hope you are learning with me. Okay. So this is the formula of this case. Why this case, this formula? Because here light is moving from denser to rarer. Okay, understood? That's only the twist. I am just showing you this is also an expectable question. So the previous one year asked, and this one is another year asked. Okay, this kind of similar, any of this pattern you can expect. Come on guys, we can solve this. What is N2? What is N2? Refractive index of the medium. What's the refractive of medium here? That's glass. What about outside? Still air. So N1 here, 1. N1 means surrounding. What's surrounding here? Air. V is the one we record to find, right? V. And what is N2? N2 means medium refractive index. What's the medium refractive index? 1.5. What is U value here? Object distance. We are applying this curved surface formula where, for this curved surface, okay? For this particular curved surface, we are applying the curved surface formula for this. So, what will be the U value for this? What is the object distance here? What's the object distance here? Could you tell? What's the object distance here? This is the object distance. You are measuring from pole of this surface to the left side, or opposite the incident ray. So U will be what? Negative here. Previous cases U is positive. Okay, remember that. So here U will be negative. How much is the U value here? Could you tell? That's exactly equal to diameter. How much is the diameter here? minus 20 centimeter is the diameter, minus 20 centimeter. So this is minus 20, which is equal to N1 is 1, N2 is 1.5. What's the radius value here? Radius of this one, radius of the surface will be, tell me, the diameter is 20, radius will be 10. Radius will be 10. But very careful, Look at this. One more chance. You guys might make mistake. So focus. The radius of this surface will be, look at this. Radius of this surface will be facing towards left side. The curve is, facing towards the left side. If the curve is left side, radius will be what? Negative. If the curve is to the right side, radius you should take what? Positive. Okay. So here, look at this curve. It is left side. Okay. If the curve is like left side, put radius is negative. So what's the radius here? Minus 10, right? Because diameter is 20. Okay. You guys can solve this. You will get the V. That's all. Lot of concepts are there. So keeps on practice this question. One of the important. Learn that curved surface formula properly and do these two questions. Okay. From the curved surface formula topic. So can you solve this then? 1 by V is equal to, this become what? Plus, right? 1.5 you can write what? 3 by 2. So you will get this is 3 by 40. 3 by 40. Alright. Then this side will be equal to what? 1 by 1 minus 1.5. 1 by 2. 1 by 2. So minus 1 by 20 you will get. Minus 1 by 20. If you solve this, you will get the V value. Minus 1 by 20 minus 3 by 40. Could you tell what the answer you got, the V value? What's the V value you got? Can you comment your answer? What's the V value you got? How much V value you got it now? Can you comment? Waiting for your answers. You guys are doing with me. V is comments properly. How much will be the V? Solve it. Should I want to solve? Yeah. Let me do then. Multiply 2 in numerator and 2 denominator, so that here denominator become 40. So denominator become 40. So if you solve this, we are getting minus 5, right? Minus 5. So if you solve that, V, I am getting like a reciprocal of that. 40 by minus 5. 40 by minus 5. Someone got the answer, I think. V is minus 8, right? Minus 8. V is negative 8. Yes, Christopher. Raji also. Yeah, V is minus 8. That means image is formed on the left side. How to draw the ray diagram? The next part is ray diagram want to draw. So what will be the ray diagram here? Here it is a sphere we have. And object is where? Object is on this side. So light is incident from these particular points. Then what will happen to the light ray? This is a normal. Here light is going from where to where? Tell me. Denser to rarer medium. So light ray will bend. So denser to rarer medium, bend away from the normal. Okay, bend away from the normal, like that. So let me mark that object positions here. Okay, so here what will happen to the light ray? It bends slightly so that you can see it will form image is you can see it will form an image at these particular positions. This will be the image. So how much you got? V is minus 8. Okay, V is minus. It's an incident ray. It's actually bent away from the normal. So the image will be, if you extend that line, you can see that V will be 8 centimeter to the left. So it's a ray diagram for it. You can draw one more light to this side. Then you can show that also. You can try. Okay, you can try. It's like a bend away from the normal. If you extend that emergent ray back, you will get the images on the left side. Hopefully that's okay to you. So these are the two important questions from curved surface formula. Try it, okay? Try it. One of the very important pattern we discussed here. So keep in your mind, lot of informations are there. Let me move to the next question, okay? Next questions. Listen to this, all of you. Yes, everybody doing with me, right? Yes. Let's move into the next question. Okay, all. Two thin lenses, another important patterns, okay? Two thin lenses, L1, L2. L1 being convex lens of focal length is how much? 24 centimeter. L2 is a concave lens of focal length is 18 centimeter. are placed coaxially at a separation of 45 centimeter. Okay, so do these questions carefully. Then we have two lenses. Lens number 1 and lens number 1 is a convex lens. Lens number 2 is what? Concave lens. Draw the diagram carefully. This is a very famous question. This kind of pattern also important. Convex lens and concave lens we have. What else is given? Focal length are respectively. What's the focal length of this lens? That is 24 centimeter. Convex is 24. Concave lens is focal length is how much? 18. But concave lens you should put negative. Focal length of concave lens and concave mirror is how much? Negative. Okay, so you should put that. Place it coaxially, common axis. What separation between them? What is the separation between them? Separation between them is given. Look at the separation between them is given 45 centimeter. Separation is 45 centimeter. A 1 centimeter tall object is placed. 1 centimeter is the object height. That's a considerably small object is placed here. You can mark. So height of that object is given 1 centimeter. Height of the object is given 1 centimeter. At a distance of 36 centimeter. Where the object is kept here? Object is kept 36 centimeter. Object is kept 36 centimeter. Find the location and height of the image formed by the combination. Where it is the final image will be formed. Or will be the final image will form. How to solve this question? Tell me. How to solve this question? Yeah, this lens, in front one object is there. So this lens will form what? Image of this object somewhere here. Then that object image is again act as a what? Object of this lens, and it will form a final image. Okay, so two lenses are there. Whenever a combination present, remember the idea. An object is here. This lens will form what? Image somewhere here. That image is act as what? Object of this lens, and form what? Final image somewhere here. So you want to apply 2 times the lens formula, then you will get the answer. That's all. Okay, so how to solve this? Come on. So lens 1, you can apply the lens formula. Apply the lens formula for lens 1. So for lens number 1, for L1 lens, apply the lens formula. What's the lens formula? 1 by f is equal to 1 by v minus 1 by u. So that's the lens formula, right? So what's the focal length of this lens? 24. So 1 by 24 is equal to, what is the v? Image distance of the first lens we record to find. Minus, what is the u value for it? What's object distance? Minus 36, right? Minus 36. So u value is minus 36. So you guys can find this. 1 by 24 is equal to 1 by v plus 1 by 36. So you can find 1 by v. 1 by v equal to 1 by 24 minus 1 by 36. Simplify this. How much you will get? Cross multiply. 36 minus 24. 36 minus 24 will be 12. 12 divided by 24 into 36. This get cancelled. You will get v is how much? 72. Am I correct? Check it, okay? Check it. So 36 minus 24, how much? 12, right? So v will be 72. Yes or no? You got v is 72. First lens formed image position 72. Are you getting so? Could you tell how much you got? That v for the first lens is 72 you got? You guys got v is 72 for the first lens? Hello everyone. Yeah, Adina got 72. So first lens formed image will be what? 72 centimeter, right? 72 centimeter. All right. Great. So first lens formed images were, first lens is forming images were 72 centimeter from the first lens. Where is 72? This gap is 45. 72 may be somewhere here. So this will be the location of what? Image formed by the first lens. 72 will be there, right? So this much is 72. Okay. So you got simple lens formula apply, you will get the answer. Okay. In case you are not completed, please take the screenshot of this one and do it. Lens lens formula, simply apply. Then could you tell here what will be the object distance of this lens? Yeah, object distance is basically distance from optic center to the location of image. Okay, so this I1 is basically what? Image of first lens. I1 is what? Image of first lens. And this I1 is act like what? Object of this. Look at this. If a series of lens is present, what's the idea? There's an object here. This lens will form our image here. Then that image is act like what? Object of this, and it will form an image. So what is this I1? I1 is the image of this lens, right? So this I1 is act like what? Object of this. Then what will be the object distance? What will be the object distance? Yeah, sir, this will be the object distance for this particular lens. So could you tell what's object distance then? It's on the right side, right? So this will be the object distance. So it's a positive. It's a positive because the right side. Okay, how much this gap? Tell me. This ender thing is 72. Then this much is 45. Then what is the remaining? 72 minus 45. If you solve, you will get that. Tell me how much it will be. It will be 23, right? It will be 23. Am I correct? 23. No. 45, then 27, right? 27, right? Yeah, 27 centimeter. You will be 27 centimeter. So apply lens formula for second lens. 1 by f is equal to 1 by v minus 1 by u. So what is f here? Minus 18. Concave, right? That's why negative. Minus 80. 1 by v value. V value we are required to find. Final image of this lens. Yeah, minus 1 by u. U is how much? 27. U is 27. U is 27. Okay, U is 27. So solve this. 1 by v equal to, very careful, 1 by 27. Minus 1 by 27 you can bring this side, positive minus 18. So if you simplify this, you will get the answer. You will get the answer. Could you simplify this? 18 minus 27 divided by 18. Cross multiplication I am doing. So if you do this, numerator become what? 9 by 8 into 27. So this get cancelled. It's become 3 here. Or become 2 here. 2 into 27 become 54, right? 54. So you will get V as minus 54 centimeter. Did you get the same answer? Image distance will be minus 54 centimeter. That means final image will be formed minus, that means back side. Final image will be formed minus 54 centimeter is the right answer. That's the location of image. And question also asking, what is the height of the image? What is the height of the image? How will you find the height of the image here? Height of the image, you can use that magnification. I will help you. You want to practice that, okay? How will you find the height of the image? Height of the image has a formula, HI by HO, magnification, HI by HO for a lens, which is equal to what? Lens case, magnification formula, V by U, V by U. I will tell the idea to you. So for the first lens, for lens number 1, height of the image of lens number 1, that's not final image, height of the image of the first lens, we can find what's HO? HO is 1 centimeter. That's given in the question, 1 centimeter tall object. HO will be 1, which is equal to V, image distance of the first lens. How much it is? 72. That is 72. So this is 72 divided by what's object distance here? Minus 36. Object distance is minus 36. If you simplify this, you will get, height of the image of the first lens. It's not final. Okay, how much you will get? Can you say that? It becomes minus 2, right? It become minus 2 centimeter. So, is it the final image height? No. For lens 2, similarly you should apply magnification is equal to HI by HO is equal to V by U. This HI is the final one. Lens 2 making image is the final one. So this HI we are required to find. What's the HO here? Height of the object of lens 2. That is image of this lens is act like what? Object of that, right? So what's the height of the object? That is equal to minus 2. That's equal to minus 2, okay? Minus 2, which is equal to, what's the image distance of lens 2? That you solved, for lens 2, what's the image distance? Minus 54. Minus 54. What's the U value? What is the object distance of that lens? That is 27. That is 27. If you simplify this, you will get the answer. HI by minus 2 is equal to, this how much it is? Minus 2, right? 27, 2 27s are 54. So if you simplify this, HI you will get how much? Plus 4 centimeter is the right answer. That's the final image. That's the final image height. It's a descriptive questions based on the lens numerical. I hope you guys got this idea, complete idea. In case you are still have a confusion, go back and watch it again. Okay, with the 2 into speed or 1.5 speed, you can watch it again. Okay, so important pattern. Remember, all detail I done here. So keep in your mind this question. Okay, so what's the key concept here? If you have a 2 lenses or many lenses, the first lens will form where the image in some location. That image is act like object of next lens, and the final image will be formed. You want to find the location of image. So remember, for the second lens, you know, you want to find the object distance from these measurements and all. Hopefully that's fine to you. Yes, all. Let's move to the next question. Next question, okay. Hopefully you guys are okay with this one. Are you with me? Are you with me now? Yes, are you with me now? I am using my brain in this question. That's why, you know, I'm like a little bit serious over here because optics is the lesson. Okay, you want to fully focus it, like a calculations. Hopefully you're okay with this one. Can you comment properly on the chat box? Can you use the proper fire on the chat box? Let me see that. Yes, all. Your all energy, show me. Yes. All right, everyone, you understood, right? Okay, let me move to the next question then. Yes, Christopher. Yeah, Muhammad. All right, let's look at the next question. Find the position of image. Yes, Kalyan, find the position of the image formed by this combination of lens. This combination of lens. It is based on, yeah, we can do this one very easily. Come on, lens formula again. Lens formula again. How to do? For the first lens, where will be the image will form? Yeah, here 3 lenses together, na? First lens will form image somewhere here. Then that image is act like the object of next. The next one will form image. That image is act like the object of next. And final. If 3 persons are standing, then you are given something to the first person. Then first person give to second person. Second person give to third person. And finally it is reaching some place, right? Similar stories. Okay, lens formula based questions, advanced questions. So here we have to find the image of the first one. Can you try that? 1 by f is equal to, you can try this, 1 by v minus 1 by u. What's f value of this? 1 by 10, which is equal to 1 by v. What's the v value? V is the one we record to find. What's the object distance here? Minus 30, right? Minus 30. So you can simplify this. 1 by v equal to, this become plus, that gone on this side become 1 by 10 minus 1 by 30. If you simplify this, you will get how much? 3 minus 2 by 10, right? 2 by 30, right? 2 by 30. So 2 by 30, how much? 15. So if you solve this, you will get V is how much? V is, you will get 15 centimeter. Hopefully you got that. Let me write here. V will be 15 centimeter. Image distance of the first lens will be 15 centimeter. I hope it is correct. For the first lens, image will be 15 centimeter. What will be the 15 centimeter? Can you mark? 15 centimeter, this is a 5. And 10, then 15 will be here. So this lens will form where the image actually, here, I1. And this I1 is what now? Object of the second lens. Okay, then you can find second lens. Second lens. What is the second lens object distance? Sir, second lens object distance is, where is the object? Here. So this is the object distance. This is the object distance now. How much this gap? That is 10 centimeter. That is 10 centimeter. So for lens 2, object distance is how much? Positive 10 centimeter. Why? Because it's on the right side. Okay. And what will be the f value for this lens? Minus 10, because that's a concave. Minus 10 centimeter. So you can find this 1 by v minus 1 by u is equal to 1 by f. So this become 1 by f plus 1 by u. You can simplify. So you will get 1 by v is equal to 1 by f is minus 10. 1 by u is plus 10. So this become 0. So you will get 1 by v 0 means what? V is infinity. So this lens, where will be to form image? It form image at infinity. It will form image at infinity. So for this lens, where it is the object? This lens made the object is at infinity. Therefore object distance is what for this lens? Infinity. Infinity. So if the object is at infinity, where will be the image will form? At focus, right? You guys can find that. 1 by v minus 1 by u is equal to what? 1 by f. If suppose u is, you are putting infinity, what you will get? Image distance is equal to focus, or that's a basic focus definition, right? So this lens will form image where? Image on the focus. What's the focus value here? 30 centimeter. So V will be 30 centimeter. Understood? So final lens will form image over 30 centimeter in front of this lens. 30 centimeter in front of this lens. So how will you write the answer for the board examination? Yeah, final image is formed at a distance of 30 centimeter from the third lens. It's clear? Easy question only. Don't forget about this pattern. Okay, don't forget about this pattern. Very, very important pattern. The last moment ray optics important question. If you check it, these are the important questions Excel team can suggest to you. Okay, so please look at this question very carefully. We are done all the part, right? Yes, hopefully it is okay to you. Whenever series of lenses there, remember the concept. First lens will form image somewhere. That image is act as object of next one. Like you should find last image will be here. Okay, that's the story. Hopefully that's okay to you. Let me move to the next question. Okay, next question. Focus on this question carefully all. Yeah, can you read this question? I hope you all understood this. Let's focus on this particular question. This is also one of the important question. Can you read this? A ray of light PQ. Ray of light PQ. PQ is the light ray incidenting on a prism like this. Okay, prism like this as shown in the figure. Two more questions there. Okay, I will finish very quickly. Don't worry. Trace the path of ray of light through the prism. You want to complete the path of light ray. What will be the effect on the path of ray if the refractive index of the prism is 1.4? Let's do this question. How to do this question carefully? Yeah, carefully you should listen. Here light is incidenting, so I think I can draw it here, the diagram. It's an important pattern. It's based on TIR. Prism is the usual repetition question for the board examinations. TIR one question is sure. A ray of light PQ enters. A ray of light PQ enters. So let me draw that PQ ray of light. It's a PQ ray of light is incident over here. This will be the angle 45 degree, which is given in the question. 45 degree. Okay, 45 degree. This with the 45 means here also with the 45, right? Because the normal, that's why. So, first part of the question, trace the path of ray of light. We need to complete the path of ray of light. What will happen to the ray of light here? Yeah, let's focus on. Will it be TIR or refraction will happen? How do you check that? Look at this. What's the angle of incidence? I will teach you in a method. Angle of incidence is how much at that place? 45 degree. When TIR will happen? Angle of incidence is greater than critical angle. This is the condition for what? Total internal reflection, right? So, what's the I value here? 45. We can check whether the critical angle is more than 45 degree or not. So, it is basically 45 is greater than C, then definitely TIR will happen. We have to verify that. So, take the sign on both sides. What you will get? Sin 45 is greater than sin C. Okay. Then sin 45 is how much? 1 by root 2. So 1 by root 2 greater than sin C. Sin C can be written as what? 1 by n, right? Because n and sin C, how they related? N equal to 1 by sin C. Okay, so that application I done here. Then take the reciprocal. When you take the reciprocal on both sides, what will happen? Root 2. What happened to this sign? Can you think? Yeah, it will change, right? It will change. It will change like this. And you know, this become n. When you take a reciprocal of this kind of thing, then automatically what happens? The sign get changes. Okay, that's the rule. So, you know, if the 45 is greater than C means what? The refractive index is greater than root 2. So, what's the refractive index which is given here? 1.5. Refractive index is given here 1.5. So, refractive index given here, the lens is how much? 1.5. How much is root 2 value? 1.414. Is it greater? Refractive index is greater? Yes, it is greater, right? It is greater. That means here the light ray satisfied this condition. Hence, you know what will happen to the light ray? TIR will happen. You understood how to check whether TIR happened or not? Yes. So what's the angle of incidence here? That's angle of incidence is 45 degree. Will it check out is greater than C or not? Yeah, 45 is greater than C. Apply sign on both sides. You will get sin 45 1 by root 2, sin C 1 by n. Rearrange. You will get this formula. You will get this condition. The condition here satisfied, right? Refractive index 1.5, root 2 this much. It is satisfied. Root 2 1.5 is more than this. So TIR will happen. So how the light ray will go? Can you guess? Yeah, it will undergo total internal reflection inside. During reflection, angle of incidence and angle of reflection must be equal, right? So that will be 45. What will be the total angle then? What will be total angle? 90 degree. 90 degree, right? That's why it's gonna perpendicular. Now at this point, what will happen? Can you measure the angle? This angle is also 45, right? This angle is also 45 because the same way it is going. Symmetry, right? Symmetry. Then if it is a 45 we already checked that angle of incidence happen what? TIR. So here also TIR will happen. The light ray will reflect. And now you can see this angle is how much? 45 degree. Now how it is gonna to the surface? Normally, when it gonna normally, it will go like this. So we got the path of the light ray. Understood? So this is the way we can learn the refraction through a prism. This particular questions. So this is the A part story. A part story. Look at the A part story. Trace the path of ray of light through the prism. That's what asking here. So we are done. Okay. I hope you understood the concept which I discussed now. Now look at this B part of the question. Look at the B part of the question. What will be the effect on the path of the ray if the refractive index is 1.4? If suppose the refractive index of this prism is 1.4, then what will happen to the path of the ray? So the B part of the question, if you carefully look, what's the refractive index they provided? 1.4. So when it is 1.4, this angle of incidence satisfies TIR condition? No, right? Root 2 is how much? 1.414. N is suppose 1.4, then what will happen? N will be lesser than root 2. N will be less than root 2. So that's opposite of TIR condition we verified, right? Okay, so therefore no TIR, no TIR. Instead, no TIR means what? Refraction will happen. Refraction will happen. Then can you say can you draw that diagram? Can you draw that diagram? Let me quickly draw what happened to this light ray. Instead of reflecting to that side, it gonna refract to other medium. How it refract? It's going from denser medium to rarer medium. Denser medium to rarer medium. So it will bend away from the normal. That means go like this. Okay, this is the normal. Here it is the normal. So it bend away from the normal like this. It goes that way. It goes that way. So that is the story happen when suppose the refractive index is 1.4. Okay, it's an important question. Hopefully you guys got this idea. Can you comment on the chat box properly? It's clear. Get it? Understood? It's clear to you all? Clear to you all? Yes. One more question I will discuss to you. One more question. Yeah, this is also a previous year question. Very quickly we can finish. Read this question carefully, all of you. In the given figure, maximum question, two more questions, last two questions we can finish, then we can wind up our discussions. Ray optics important part. In the given figure, the radius of curvature of the curved surface of the plano-convex and plano-concave. Plano-convex here, plano-concave here. How much it is the radius? 10 centimeter. Refractive index how much? 1.5. Find the location of final image after the refraction. Where is the final image will form? Where will be the final image form? That's very simple here. Okay, this is a previous year board question. Here you know the light rays, how it is coming? Parallel, right? Parallel light ray, where it will converge? Focus. So you want to find the focus of this particular lens. How to find the focus of this particular lens? Look at this. The focus first you should find. How will you find it? 1 by f. Focus of a lens, how will you find? That is n minus 1 into 1 by r1 minus 1 by r2. Lens maker's formula you can use. So 1 by f is equal to, what is n? N means refractive index of the lens. How much it is? 1.5. So 1.5 minus 1. What is r1? Radius of the first surface. What's the radius of this one? Look at this. The surface is plane, right? Radius of the plane is how much? Infinity. Radius of the plane is infinity. What's r2 value here? Radius second surface. How the second surface? Facing to the left side. So radius will be negative. What's the radius of this one? It is also given. Radius is given how much? 10 centimeter. So it's minus 10. Why it is minus 10? Because that's facing to the left side. That's why. Okay, 1 by infinity is how much? 0. So you will get 1 by f is equal to 1.5 minus 1, 1 by 2. And 1 by infinity, 0. Minus plus. So it's become what? 1 by 10. So you will get what? F is equal to 20 centimeter. F is equal to 20 centimeter. So first lens focus will be what? 20 centimeter. Where it is 20 centimeter? Somewhere here. Because this is 10. So this will be the image formed by the first lens. Why it is on the focus? Because this parallel incident ray. Parallel incident ray after refraction, it meet on the focus. Where is the focus you determine? Focus you determine how much? It is 20 centimeter. Understood? Then for this particular lens, where it will be the final image will form. Yes, to find the final image, you record this what? I told you, know, this I1 is act like what? Object of this. So can you find the object distance of this? Yeah, object distance will be, look at this much is 20, this much is 10. Then what's the remaining? 10 centimeter, right? This entire thing is 20. This will be how much? This will be 10. So remaining will be 10 centimeter. So here is the problem. You again want to find what? Focal length. How to find focal length of that lens? 1 by f is equal to n. What's the refraction of this lens? 1.5. 1.5 minus 1 into 1 by r1. What's the radius of this side? That's to the left side. So it's negative. Negative 10. 1 by negative 10. What's the radius of other side? It's a plane. Radius of plane is how much? Infinity. Plane is infinity. So automatically what will happen? It will get 1 by infinity is 0. So 1.5 minus 1, 1 by 2 into 1 by negative 10. So f comes to be how much? Minus 20 centimeter. It's clear? Focal length is minus 20 centimeter. So focal length of this lens is minus 20 centimeter. Hence you can find the image how 1 by f is equal to 1 by v minus 1 by u. 1 by f is equal to 1 by v minus 1 by u. So 1 by minus 20 is equal to 1 by v. What's the v value? V value we require to find. What's the u value? U value is 10. U value is 10. So can you solve this? You can find that v value. Quickly find, all of you. Just quickly find 1 by v is equal to, 1 by negative 20 plus 1 by 10. You guys can find that. Good question, okay? So please remember this. So hopefully you will manage this one. 2 you should multiply numerator denominator, and minus you can multiply. So you will get 1 minus 2. 1 minus 2 how much? Minus 1. Minus 1 by minus 20. So v also you will get what? I think 20, right? V will get 20. Is that correct? No, V is minus 20, right? What you got? V is minus 20. V is minus 20. You will get V is minus 20. If you calculate that, check it, okay? Am I correct or not? I am doing fastly. So V will be minus 20 centimeter is the answer. That's fine. Got it? The last question you want, I am just hand over to you. This one is a very important question. If we cut a convex lens, very important, I'm just giving that information to you. If you cut a convex lens like this, okay, along the principal axis, you're gonna cut like this, then what happen? You will get a 2-piece like this, okay, like a birthday cake, you will get like a 2-piece like this. Then question is asking what will be the change in focal length. What happened to the focal length of this lens? Will it be changed? It will not change. Focal length remains same. Remember, it's an MCQ. Every type question they can ask, focal length will be constant. Why focal length is constant? Because focal length according to lens maker's formula, it depends on what? Depends on refractive index and radius. So when you cut like this, are the radius are changing? Radius are not changing. The curve radius is not changing. And medium inside, refractive index also not changing. So focal length will not affect. Focal length remains constant. When you cut a lens, you can cut a lens by 2 ways, either like this or vertically. So focal length remains same if you cut like this. What happens when you cut like this? That's the second part of the question. When you cut like this, you will get, this kind of 2 individual pieces. This time focal length will change. Why so? Because radius get changed. This surface has different radius. Here, when you cut like this surface and that surface, radius remains same in the new piece also, obtained piece also. So here focal length will changes. You can comment your answer. What will be the focal length you got? What will be the focal length here? Focal length to become, you can find that focal length. How to find the focal length of this each piece, f dash and f dash? The total focal length, say it is f. Then how will you find, no? When you combine these 2 lenses, you will get like this. So I can use the combination formula. Let me quickly tell you that idea. 1 by f dash plus 1 by f dash. 1 by f is equal to 1 by f1 plus 1 by f2. 1 by f dash plus 1 by f dash is equal to 1 by f. So 1 by f is equal to 1 by f dash plus 1 by f dash means what? 2 by f dash. So f dash, how much you will get? F dash you will get 2 times f. That means focal length of each piece become what? Twice the original focal length. Twice the original focal length. Understood? So remember, when you cut a lens like this, focal length remains same. But when you cut a lens like this, focal length become what? Doubled. Keep in your mind these informations. It can be asked in board examinations. Hopefully that's clear. I think some of the comments are coming based on this. The calculation I quickly done. Can you check that calculations again? I hopefully you will manage that. Should I want to do that? Yes. Did I made any mistake over here? Check it, okay? Please check it. So 1 by negative 20 is equal to 1 by V minus 1 by 10. So 1 by V is equal to 1 by negative 20 plus 1 by 10. So the calculation become 1 by negative 20, 1 by negative 20 plus 2 by minus 2 by minus 20, right? I can do like that. So if you do this calculation, you will get 1 minus 2 minus 1 minus 1 by minus 20. Yes. So you will get V is equal to plus 20, right? V is equal to plus 20. Hopefully you got that. I'm rushing. That's why, the calculation I'm not taking care that much. So I hopefully you will manage that. That's the simple self-explanatory content. You guys definitely the cross multiplication, etc. I'm focusing on the concept. Did you get this? Please note, if it is a new information, please add on this point. So we done all the ray optics, some of the important questions we covered. So must do this one. So I hope you guys are tired. Sorry for it. Yes. So thank you guys, all of you. Best of luck. All the best. We can see tomorrow. Bye. Thank you.